Hello everyone, my name is K. Chanchireddy, working as the assistant professor in Tigala Krishna and Engineering College. In this video, I will explain multi-carrier PW techniques. In my previous video, I designed level shifted PWM techniques and phase shifted PWM techniques. In phase shifted PWM techniques, I designed one video, and level shifted PWM techniques have three types. One is PD and P body and AP body. Okay, phase disposition and phase opposite disposition. Okay, AP. In my previous video, I designed in level shifted PWM technique, PD control technique. Now in this video, first I will explain difference between the PD and POD and APOD. Okay, first this multi-carrier PWM techniques classified into two types. One is low frequency switching device, next low frequency modulation, next high switching frequency. Okay, in this level low frequency switches divided into multi-carrier pulse width modulation. In multi-carrier pulse width modulation divided into phase shifted, and the second one is level shifted. In phase shifted modulation technique, only single switching frequency. Next, level shifted modulation divided into three types. One is phase disposition PW technique and phase opposite disposition PW technique. Next, third one, alternate phase opposite disposition PW technique. Here three. And now I will focus only these three techniques: PD and POD and APOD. Okay, these are multi-carrier PW techniques. Here, level shifted PW technique. In level shifted PW technique, PD means phase disposition PW technique. In phase disposition, all carrier signals are in same phase. Here, this first carrier wave, it varies from 0 to 1 and 1 to 0, minus 0.5 to 1, 1 to 0.5. Next, again 0.5 to 1. This is one carrier wave, this black color. The second one is 0 to 0.5 and 0.5 to 1, 0.5 to 0. Next to 0.5 to here 0 to 0.5, 0.5 to 0. Next to 0.5 to 0. This is second carrier signal. Next, third carrier signal, it varies from minus 0.5 to 0, 0 to minus 0.5. This is third carrier signal. Next, in this fourth carrier signal, it varies from minus 1 to minus 0.5. Next, minus 0.5 to minus 1. This is fourth carrier signal. In four carrier signals, in the phase disposition, all the carrier signals are in the same phase. Okay, these four carrier signals are in same phase. This is phase disposition PW technique. Next, this one, phase opposite disposition PW technique. In the phase opposition disposition PW techniques, all carrier signals above the 0. Above the 0 means this is 0 here, 0, 1 and minus 1. In this above the 0 are out of the phase. Okay, above 0. Next, below the 0 by 180 degrees. Okay, if in above 0, these two are in same phase. This below 0 are 180 degrees phase shift. Okay, opposite to this carrier signal 1 and carrier signal 2 in same phase, carrier signal 3 and carrier signal 4 same phase, but 1, 2, 3, 4 are 180 degrees phase shift. Okay, here name is phase opposite and disposition PWM technique. Next, alternate phase opposite disposition PWM technique. In this alternate means here this first signal, carrier signal, and the second carrier signal, these two are opposite 180 degrees. Next, this third carrier signal and fourth carrier signal here opposite. Okay, this varies from 0, minus 1, 0 to 1 to 0.5, 0.5 to 1, again 1 to 0.5, like this. Now I will design this alternate phase opposite disposition PW technique in MATLAB Simulink software. Okay, now I will design this circuit in MATLAB. First, I will go to MATLAB. I will take commonly used block scope. Next, I will take one relation operator. Next, I will take one logic operator. Next, in signal routing, I will take one from block and I will take one go block. Next, in sources, I will take one repeating sequence and one sine wave. Now I'll start designing the circuit. I will drag one by one side and this relation operator. Okay. First, I will apply the sine wave to first one. Next, the second repeating sequence I will apply here. I will give here sine wave values. Amplitude is sine wave. I will apply 0.95. Next, I will apply here frequency 2 pi into radians per second, 50 hertz frequency. Now I will give here repeating sequence values. I will give here 0.5, 0.2 and 0.4. This is time values. Now I will operate this one 500 hertz frequency. Time t is equal 1 by f. I am operating this total switching frequency 500 hertz. That's why I took here 500 hertz. I took only 3 values. In opposite disposition PWM technique, it varies from first carrier 0.5 to 1 and 1 to 0.5. That's why I will give here 0.5 to 1 and 0.5. This is carrier, first carrier wave. I will apply this one. Next, I will take second carrier. I will second carrier. I will compare. So this is second carrier. I will correct second carrier here. In second carrier, it varies from 0 to 0.5, 0.5, and again 0. I will explain this. The second carrier, it varies from 0 to 0.5 and again 0.5 to 0. Cycle repeating like this. Now apply this one. 0 to 0.5, again 0. Next, I will take third repeating sequence. I will compare this third repeating sequence. This one I will connect it to sine wave. In this third repeating sequence, it varies from 0 to minus 0.5, minus 0.5 to 0. Here I will apply minus 0.5 to 0. Again minus 0.5. Okay, this is third repeating sequence. Now I will connect fourth repeating sequence here. This fourth one. Next I will this first one connected to sine wave. Now this fourth one, it varies from minus 1 to 0 and again minus 1. Here minus 0.5. Okay, now I will show a phase disposition technique in output waveform. Dashboard. We'll go to signal routing. I will take one mux block. I will add this one. Okay, now I will double click this mux. I will give here number of inputs 5. Okay, I will give here number of inputs 5. First one I will connect it to the sine wave. Second one I will connect it to repeating sequence 1. Third one connected to repeating sequence 2. Fourth one connected to repeating sequence 3. The fifth one connected to repeating sequence 4. Now I will connect here. Now I will run the circuit. Okay, I will show output waveform. Okay, once see here this first one and second one. This third one, it varies from 0 to minus 0.5, 0.5 to 0. So I will change here. I will go to this one. This third one, it varies from 0 to minus 0.5. Again 0. Next, this one also I will change. Minus, fourth one I will show you. Minus 0.5 to minus 1. Minus 0.5 to minus 1. Again minus 0.5. Otherwise, this name is phase disposition PW technique. I am designing POD, phase opposite disposition PW technique. That's why I am changing here values. Now again I will run the circuit. Okay. Now we'll show waveform. Okay. These two are same in phase. These two are opposite 180 degrees. This technique name is phase opposite disposition. Opposite disposition PW technique. Okay. Now I will show this waveform. This is phase opposite disposition PW technique. Now I will connect this PWM signal by using this control scheme. I will connect 5-level cascaded HBridge 5-level inverter. Now I will design circuit. Before designing circuit, I will apply here pulses. I will generate 8 pulses. I will take here NOT gate. I will connect here first. The switches are first to S1 and S2. Switch S, this is S1. This switch S1. This second switch S2. Will apply here greater than or equal. Next, this switch is S3. This switch is S3. Now this switch is S4. This switch is S4. We will also greater, I will apply this greater than equal. Next switch, this switch is S5 and this switch is S6. This switch is S5 switch. This switch is S6. Next, this is last S7 and S8 switch. This switch is S7. This switch is S8. Now PWM pulses control scheme circuit I generated. Now I will design cascaded HBridge 5-level inverter. I will go to Simscape. In Simscape, I will click here power systems. In power systems, I will go to specialized technology. In specialized technology, I will take one voltage source. In elements, I will take in fundamentals elements, I will take one branch. RLC branch, I will take one voltage source. In power electronics, I will take one IGBT switch. Now I will design a cascaded HBridge multi-level inverter. First, I will rotate this switch, IGBT switch. I no need this E. E means this is measurement port. Show measurement port. I will remove this measurement port. Next, I will rotate this left to right, this power electronics switch. We'll right click this switch. This here rotate option is there. Rotate flip. In flip black here left to right option is there. Click here left to right. I will take total 8 switches. Now I will connect this positive connected to this C, and again this second connected to I will here. Next this E connected to C. Next here also I will connected to, within a second orbits I will connect. Next I will copy and paste the circuit. Copy, I will paste. Okay, this one. Okay, now I will connect it to the second one to here middle. This positive connected to here. This negative connected to here. The voltage. Now I will connect the switches here. Total 8 switches. In my previous videos, I will explain how to use from block and blow block. Okay. If you want learn how to use this from block and blow block, you search video in my Simlink, my YouTube channel playlist here. Simlink videos. I will apply this. This is switch S1. This is S1. This second switch. This is S2. This is switch S3. This switch S4. Okay. The signal supplied to here. Next, I will take one more switch. This is S5. S5. Next, this switch is X6. This switch S6. Next, this switch S7. This switch S7. This last switch S8. Now I will change here. Less than or equal. First greater than or equal, second less than or equal. Again this third one greater than or equal. Fourth one less than or equal. Now I will take power guide. I will take power guide. Now I will connect scope across the load. I did not connect load. First I will check output voltage, open loop voltage. Now I will run the circuit. I will show output voltage. Okay, I got 5-level voltage. It's showing. I will take this here. Now I will change here. I will give input 200 volts. The second also I will change here 200 volts. Input voltage. Now I will run the circuit. Okay. Now I got 400 volts output AC. Okay. Here it varies from 0 to 0.5, one full cycle. Positive. First this is 400 volts voltage. We have level 1. Next level 2 here 200 volts. Level 3 this is 0 volts. Level 4 minus 200 volts. Next level 5 here minus 400 volts. Total here 5 levels. Now I will connect here load across the resistor. I will connect load across the voltmeter. I will apply here 100 volts, 100 ohms. I will connect this R load across the voltmeter. This first one connected to here. Negative terminal connected to here. Now I will run this circuit. Now I will run this output. Okay. When I am connecting load here showing only 3 level output voltage, one is 400, second 0, third level is 400. When I am removing this load, okay, in open circuit here showing total 5 levels. Okay. Now I will check total THD value of this waveform. I will remove this limit data point. Next, I will go to history. I will save this one. V0. I will apply here. In save here format in structure with the time. Okay, click here structure with the time. Now run the circuit. Again, we'll go to this power guide. Double click here power guide. In power guide, we go to tools. In tools here FFT analysis. Click here FFT analysis. In FFT analysis, I will show how to check THD value. Okay, here V0. Check what time saved in. Sorry. Okay, I have V0. Now I will show here V0. In this V0, I will apply here 50 adjust frequency. Next, I will take here number of cycles 3. Number of cycles means here cycles. Now I will take THD value from first 0.02 cycles. Okay, when I am applying here 0.02 seconds, this THD value start from 0.02 seconds. Now I took 3 number of cycles. If I increase the number of cycles here 5, this color also red color 5 number of cycles. Fundamental frequency after here 50 adjust frequency. Okay. Now I got THD value is 30.80. Okay. This is the total harmonic distortion value in 5-level multi-level inverter. 5-level inverter cascaded HBG inverter 30.80. Now I will save this output waveform with the high resolution. First I will double click this here. Try time scope. I will double click this one. I will double click this one. After double clicking, here file option is there. Click here file. In file, go to print figure. Okay, go to print figure. Here edit option is there. In edit option, go to figure properties. Go to figure properties. In figure properties, click here property edit option. In property edit option, click here white color. Okay. Next here also change this color white. Now I will change output waveform color. Will apply here red color. I will change font size 3. Font size 2. I will apply. Next I will change here borderline color black. Okay. If you want to change this borderline thickness and font everything, click here font option. Okay. In font option, I will change here font size 14. Okay. Now I will change here bold color. If I change here bold, here also change. Now if you want to write x-axis and y-axis names, type here x-axis. X-axis, I will type here time in seconds. In y-axis, I will type here output voltage. Output voltage. Okay. This is output voltage. If you want to save for publication purpose, IEEE format, save like this. Here choose. If you publish a finger paper like this, We will select total full paper. For IEEE paper for publication purpose, choose like this. Okay. If you want to change here number of pulses, we want to change x-axis length. I will apply here 0.1. Okay, cycle like this showing. Now I will save this output waveform. Now I will save this output waveform. I will save this output waveform with the JPG format. I will click here save as. Save as. I will select desktop. In desktop, I will save name with V0. Here select I will select JPEG format. Now I will save this waveform. Okay, now I will save waveform. How it was saved. Okay. Okay, this is the finally output waveform. 5-level cascaded HBT multi-level inverter waveform with phase POD technique. Okay, phase opposite disposition PWM technique. Okay, thank you for watching this video.